Most electrical disturbances are short-lived. Certain devices generate harmonics, not all devices. My name is Eric Solo, and I'm the owner and managing director of Alpha Power Solutions. And today we're talking about harmonics, what they are, and why we should care about them. Most electrical disturbances are short-lived. They're extremely short in duration and they are not repetitive. It's an incident that is not repetitive. Harmonics is a form of electrical pollution that is constant or relatively constant. Harmonics are not incidents and they're always present as long as the devices creating the harmonics are in operation. I use the following analogy to explain harmonics to my customers. Harmonics can be seen as sewage. And imagine you have one toilet on the edge of a fairly big river, and you allow the effluent from the toilet to go straight into this large river. The impact on the general pollution level present in the river is actually not so significant and might even still be safe to drink. But imagine now that you have not one toilet, but 10 toilets, all feeding in sewage into the river. Now you have a problem because that the total amount of sewage now makes the quality of the water unacceptable. So how do you fix this then? Well, the one solution is to actually take all the water from the river, divert it to a treatment plant, and actually filter it out and then put it back in the river system. That can be done, but it's extremely expensive. But sometimes you have no option but to do it that way. The alternative solution is to actually put a sewage pit close to each toilet, purify the sewage in the septic tank, and allow then the treated water to go into the river. That's the next solution, and it's often the most cost-effective solution to address harmonics present in the system. Certain devices generate harmonics, not all devices. Typically, equipment that generate harmonics are variable speed drives or frequency drives, LED drivers, UPSs, inverters. We call this type of equipment non-linear loads. If the harmonic levels in an electrical distribution system are significant, this can result in the failure of electrical equipment, electrical and electronic equipment, overheating of electrical cables, and the tripping of electrical protection devices that shouldn't have tripped. For example, circuit breakers that trip even though they haven't reached current that would have caused them to trip under normal circumstances. The steps that businesses can take to mitigate the effects of harmonics present in their system and improve the power quality of their electrical system is, of course, to first start and carry out an audit of the harmonics and those devices that do generate the harmonics. So the idea is that you do not reduce the harmonics completely. A certain amount of harmonics that are totally acceptable, and there's rules and regulations and norms available that indicate what is safe and what is acceptable. So it's not necessary to fix the whole plant or the harmonics in the whole plant. You just need to find key contributors of the harmonics, and the usual 80-20 rule applies. You need sophisticated equipment to be able to measure those harmonics and to come up with the solutions. There are two solutions possible. One is installing what is called a passive filter by the devices that generate the harmonic. So these devices prevent the harmonics from leaving the device, for example, a variable speed drive. They will remain contained within the variable speed drive, and they're unable then to travel upstream and affect other. The other solution is to put active harmonic filters, and these devices create harmonics that are the exact opposite of what is present in the system, and in so doing, you basically cancel out the harmonics that are present in the system. The active harmonic filters are rather expensive. They have certain applications where they make a lot of sense. Usually, by addressing the main polluters, it is usually the cheapest option. To come back to the example I gave about the sewage or the toilets along the river, the sewage pit by each toilet would be a passive filter, and the diversion or the treatment of all the water in the river, but it can be done. Power factor and power factor correction are principles that are not easily understood. In Europe, in America, in Australia, when you have a business that has a bad power factor, you get fined. The fines are significant. And in those countries, the payback period of an investment in power factor correction is not calculated based on the reduction of power usage. It's simply measured as through the fine avoidance. In South Africa, the municipalities and Eskom do penalize you, but they want you to, well, especially the municipalities, want you to consume as much power as possible because it's a source of income for them. So they want you to use as much power as possible. You are actually being fined, but it's hidden in technical jargon. And unless you're operating in this field of these, you will not understand that you're being fined indirectly or call it maybe overcharged. There's so much opportunity for business in South Africa to address this issue. In Europe and America, they also don't understand, most people don't understand the concept of power factor and power factor correction. But they do understand the fine because the fine comes on your bill as a fine for poor power factor. So everyone's got it because the fines are punitive. As far as I know, in Africa, the only country that imposes a clear poor power factor fine is Zambia. The fines for poor power factor in Zambia can be significant, up to 50% of the total electricity. So a lot of focus is there to optimize the energy usage of the businesses in that country and freeing up capacity to be able to give more businesses power because they have a major power constraint. But in South Africa, that's not the case. And so it's a continuous education of our clients trying to explain, what the benefits are, how it works, and the necessity to keep the equipment operational. If the equipment doesn't work for as much as 30 minutes during peak production time, you will lose all your savings for the month. And in certain municipalities, you lose the savings for the following 12 months as well. So maintenance of the equipment is crucial, and also the quality of the equipment is crucial. The equipment has to work 24/7, 365. And we offer support to our customers where we can remotely assess the condition of the equipment, get notification of alarms present in the system, and we can then send technicians to address or repair the defects that are present in the power factor correction plan.